firstly, thank you very much for giving me opportunity to interview you for my YouTube channel and podcast.
Yeah, this is great, Sai.
So I thought to tell about you and the work that you are doing to my audience.
Sure. What I've done for about 7 years now is a robotics course at my high school. And it's been a really good experience, but all the students, they learn the sensors that you can hook up to microcontrollers, and then the actuators, the motors, and their final project, they always want to do something bigger than the microcontrollers can handle. You know, instead of 3 servo motors, they want to do 5 servo motors or something to that extent. So a year ago, I found the Arduino Portenta, which is this little beast. And it has some pretty impressive abilities. It's dual core, kind of like the SP32. It's dual core. It's reasonably fast. It can do some machine learning, and at the time, I was reasonably interested in machine learning with TensorflowJS, a JavaScript version of TensorFlow's platform. And so for about a year now, I've been researching the Portenta, and it's not necessarily an easy Arduino board, but it has a ton of potential, and the latest version, 2.6.1 of the board manager on the Arduino, is really quite stable and solid. So that's where I'm at. Is I start on Monday this brand new course, which I've been developing, and it'll be really fun. It'll be really interesting because it's never, with students, it's never how you expect it's going to go. Something that should be easy tends to be tricky, and then other things that you think they might have a hard time with, they just breeze along. So that's where I'm at. I'm looking forward to Monday.
So you're working on this right now.
Yeah, it's been a year in developing, and I'm sort of doing the same course I've done for the last 7 years with a different microcontroller, but now with bigger, better capabilities. The interesting thing with the Portenta is it pulls apart, not very easily, into this vision shield, which has a microphone, an SD card, and LoRa radio, and then the main board. Let me get out of the way. The main board, which I solder female headers on. Normally you have male headers going down so it can go into a breadboard. But if you put the male headers on, then the vision shield can't attach to the back. So yeah, we're working through a few of these things, and it'll be interesting to see how the students like it and how easy it is to work with. Yeah. To support that, I have a GitHub Maker 100. That's the course we'll be going through. So most of my robotics, I have a quick video that just shows the students how to do one particular thing. And then in class, I'll fill in the safety features, the background, and the video should be just to get them enough information to set up without a whole bunch of technical jargon. My view is I want the kids doing hands-on robotics without, slogging through a whole bunch of background information. Just fun and quick, get it done so that the students can be creative with it. I push my kids to, if we hook up a sensor, to then do more with that sensor. And so there's a GitHub Maker 100 course. And then I have a library which has an Arduino library, which you can search when you're on the Arduino IDE. You search for a community, and then the library is called the Portenta Pro Community Solutions, and it's just a ton of examples. So a kid who wants to work on their own can load up this library and work through some of the things that I've pre-tested on the Portenta. Yeah, so that's where I am with that. I'll have probably more information in a few months. Yeah.
And you also are into Edge Impulse.
Well, that's where I mentioned I was working with TensorflowJS. I was doing similar things, making examples that were easy enough for kids to work with. And then I ran into Edge Impulse. It looked like we were doing similar things. I was trying to get machine learning onto the microcontroller, and Edge Impulse is this company that puts machine learning on lots of microcontrollers. So I have seen what they can do with the Portenta, and it's pretty amazing. They have an IDE. It's not Edge Impulses, but it works with Edge Impulse, called OpenMV, and it does Python. And Python's very good for machine learning, so it's really, really quick. Tons of examples that the kids can work through. I stick with the Arduino C++, which is much, much slower to compile, but theoretically, the final machine learning might be a little bit quicker. And so that's what I've worked with Edge Impulse to try to get the Portenta code working smoother and easy to work with. I'm not sure if you've done Edge Impulse, but it really is quite amazing. A kid with a cell phone can start making a model. Typically a 40-minute class. We have kids with running machine learning models, vision models that they understand and can test, and can show me a confusion matrix of how well it's working, and a feature explorer also that shows how well it's working. And I'm talking grade 10s. They really like Edge Impulse. The hard part is now that's where I need my students to be actually pretty good at computer coding, because there's some parts there that are a little bit more complex. And so that's what I'll be working out this semester is, can all the kids do it, or is it just a small group of kids that can do that more complex part working with the code? So now you've got a machine learning model which can do what you want. I can't really show you my screen, but I can probably show you something that, this is all dev, just proof that things work or don't work. So what I've got here is the Vision Shield on the back of a PCB that I've made. And then there's the Portenta on the front. And then it's probably upside down, and it just came out. So I'm just going to have to plug that in a little bit. I've got one cable. There's always one cable that you just want to solder. Anyway, that's... I can't really see if it's even working. Are you seeing some numbers there or anything? Yeah. So that's... Oh, it was probably showing my arm. And I'm not sure if it's upside down or whatever. But that's a machine learning model which is identifying bottles or pop. And the idea being, one of my after school groups, we've got these RC cars, and this is the old, it doesn't have the microcontroller on it, but it's got the board with the motor drivers. So we would be trying, and this is still on the developmental stage. I've proven that the software works. Now can the kids get it so that it can drive a car? When it sees a pop bottle, it's supposed to turn right. When it sees a water bottle, it's supposed to turn left. And by wiggling, it should maybe go around a track. It's fun working with the RC cars. we take out the RC part and throw in an Arduino. Kids quite like that project, but as I said, we've got the concepts working. Now can they put it together and make a car, not self-driving, but at least drive around a track, with the idea that if you change the bottles and the pop, your track would change and the vehicle would drive through it. Probably shouldn't be talking about it till I've actually got proof of it working, but the concept works. So that's what I do. I teach sensors, I teach actuators being motors, and then it's kind of up to the kids to figure out what their final project is.
So what is this Portenta?
It's an Arduino. It's this thing. And I don't know all the stats off the top of my head. It has about 30 pins there in female headers, which is pretty typical of a microcontroller. But what's interesting with the Portenta is it has two high density connectors on the back, which means instead of just the 30 pins, which most microcontrollers will have about that, we actually have access to about 160 pins. And that's where it's quite different from most Arduinos and Arduino-like microcontrollers, is you've just got so much potential power. That's the side project I'm working on, is this board. It's a PCB board, made it using Easy EDA and then purchasing it from JLC PCB. This one's not perfect yet, but you can see I have access to the 160 pins. I plug in my Portenta and the Vision Shield on the back, and hopefully that will give kids more access to the power of this board. These miniature computers are really quite impressive. Arduino isn't the cheapest. The main board is about $100, but the big push is it's the easiest, and they really support their boards. There's typically a forum where someone can help you, or you actually talk to the people from Arduino, and they can help when there are problems. And I must admit, a year ago, there were a lot of problems with, some of the pins not working or some things, the software not quite ready. But now, a year later, things are much more solid. So that's the Portenta. It's a pretty fancy microcontroller. And that's what I'm pumped about, is I'm making my robotics project course better, more powerful. Yeah.
So you give robotic classes?
Can you say that again? I give something about a class?
You give teaching for the kids about robotics.
Yeah, in Canada, robotics typically is a teacher might be really interested in it, and they'll make a club for some competitions. And you can buy some either Lego Mindstorms, or I think there's a project called The First, and they're great engineering competitions. So you would take your 10 kids somewhere and have a competition where you're trying to use these robots to collect balls of the right color or move them around. And it's really exciting, but I wanted to teach a course. And I already teach computer programming and 3D printing and animation using Blender 3D. And I just wanted to teach a robotics course where, as I've said before, I show a kid how to use a sensor, a flex sensor, or a touch sensor, or temperature, or a light sensor. And then I show them how to use motors like stepper motors, or servo motors, or DC motors, or just some kind of actuator like an LED light, or making a sound. And then instead of it being an organized competition where the rules are very, this year you have to drive your car and turn left after 2 meters or pick up some balls, which they're great competitions. I just wanted to have my students know the basics and then come up with a project that they think is either fun or useful. And kids have made robot hands, they have made sensors, they've made GPS sensors. It's really interesting what they can put together. Are you familiar with IFTTT? If this, then that?
No.
Oh, okay. It's worth searching. It's a website where you can allow your multiple things you do on the computer to interact. So say I want my text messages and my Twitter feed to, so when the Twitter feed says something with a certain word, I get a text message or an email, or this interconnection of your different things you use, IFTTT. And there are a bunch of other ones like IFTTT. I think Arduino has a similar cloud ability that can connect your different devices. Well, the Arduino is another device. So say you have something that's sensing water. When your Arduino sensor, moisture sensor, detects water, then your Arduino could send to IFTTT to send you a text message or a notification on your phone. Now it starts getting useful. Say this device is in your basement and you want to make sure there's no water in your basement. Well, now your cell phone can alert you to if there's water in your basement. It becomes functional. And so that's another interesting connection between your sensor actuator. The IFTTT is your actual actuator that your Portenta is sensing something and then sending it off on the internet to alert you or communicate somehow. Yeah.
So you are into IT from last 40 years.
I've been computer programming since I was in grade 8. And yeah, the programming is one part. I've only done the robotics for about 7 years, about that length of time with teaching animation. And I've only taught 3D printing for about 5 years. Yeah, it's been a long haul with technology, and it's fun. It entertains my brain when I'm not in front of the computer, because coding you can think about wherever you are. I like that part. There's always multiple things to work on. There's always something to look forward to that you're going to try next. As I mentioned, I'm building PCB boards, and 3 months ago I'd never made a PCB board before, and it's just amazing how technology makes things easier. So now I'm making PCBs. And this PCB is actually quite difficult because it has those high density connectors. Look at this thing. That right there and there are the high density connectors, and soldering those are quite insane. If a kid can solder that, they can probably solder anything. So that might be a year before I'm doing anything that complex with the kids, but we'll see. Every class is different. Some classes you have a few kids who really like to push themselves, much like yourself.
So you're working on Portenta. So how it is helpful and works in the real market?
Say one more time. How does this help with the real market?
Yeah, with the real world, with the real things.
Well, as I mentioned, my students do a final project, and there is supposed to be a bit of a tone of, is this project going to be useful? Is it fun? Would someone like to purchase it? And that's an interesting dilemma, because It is an Arduino, an unofficial Arduino, which are not the cheapest boards out there. I choose them because I've got all this support. I can actually talk to the developers from Arduino. But because it's not cheap, that brings up the point. If you were now, you've got your product working, you've got your proof that it works. Now, how do you make it cheap enough that it's going to make you some profit? And I would kind of like to think of the Portenta as your high end. If you can sell this, you now have something that's pretty impressive, because then you can start working on making it cheaper. And there are dual core microcontrollers out there like the ESP32 that are ridiculously cheap. $10 for one or two. If you're buying in bulk, you might even be able to get it down to like $1. So this is the step that none of my kids have got to yet. But say they come up with a project which people might find really impressive. The next step is, how do you make it cheap enough that you can make some profit? The cool thing with the Portenta is you've got proof that it works, and people are looking at it like, hey, that's a cool product. I've got a $100 microcontroller with a $65 shield. Already your cost is getting close to $200 just to have a proof of concept. So there's a real engineering dilemma there of how can I make it cheap enough that people are going to purchase it. And I like the proof that it works. And that's for a kid to take on and see what they can do with that. Machine learning product made by a student is pretty impressive. And that's where Edge Impulse makes things so much easier. The programming part's the interesting one that it'll be interesting to see. As I said, I've done robotics for several years, but I've never done robotics that the machine was powerful enough to do machine learning. And that's really interesting, because machine learning is different than computer coding. You have to teach the machine what you want it to learn. And then on top of that, you put in the computer coding so that it does what you want it to do. So it's really exciting to be able to bring this to students.
Awesome. And Edge Impulse and helping hands-on robotics for kids. Tell me more about this.
I'm actually on pins and needles waiting for a grant. I've applied for an $8,000 grant to get technology for the Indigenous kids at my school. And supposedly the check is in the mail. So I've been going down to the school office every day and saying, is there any mail for me? Because I kind of don't really believe it's real until the money arrives. Now, the concept with this, your typical teacher would apply for a grant to make like a makerspace. And then that makerspace, kids can come to the makerspace and work on projects. And typically you would have a teacher like myself or someone from the metal shop who would be at the makerspace who could help the kids. And it's a great concept. The problem with it is it needs a teacher or an adult, a skilled adult, there for kids to drop in. Well, my take on this is I want to purchase the equipment for the kids. And then the kids are welcome to bring it to school if they're in my class, to use it in the class if they're not in the class, to look at some of my videos and see if they can do any of the technology from home. And I've taught several kids who just, if they want to get into electronics, they just, let's buy a Raspberry Pi, let's buy an Arduino, let's do some work, let's buy a bunch of sensors, and they'll do that at home. That's not a reality for all kids. And so this grant hopefully will get, first of all, the Portenta with Vision Shield into their hands, take it home, work on it from home, work on it from school. And I've got this series of about 6 steps where the first step is they've got to go to Edge Impulse and make a machine learning model. I've already mentioned that's quite easy for kids to do. And if they get that done, and they're one of the kids who are going to be helped by this grant, they would then get the Portenta and the Vision Shield. So now let's go do some work with the Portenta and the Vision Shield. I mentioned I've got a library called the Portenta Pro Community Solutions, and they can load up some stuff and see if it works. But they don't have any sensors or actuators. So they can't really do anything other than proof of software working. So if they get to that point where they're now comfy with the software, this grant should allow me to purchase them sensors and actuators. So now the student can take home, a flex sensor, a GPS sensor, a distance sensor, temperature, light sensors. And the grant should allow them to have DC motors, motor drivers. That's the important one, where you don't have high voltage going through the Portenta. It's made for 3 volts, but motors typically want 5, 6, 12 volts. And so for the students to understand that you have a motor driver between the Portenta and the motor. If they get that level done and they figure out some get things working, I typically have them make videos. And so my marking is watching a video of the Portenta hooked up to a motion sensor. And so the marking's ridiculously easy. 10-second video proves to me they got it done. What's the next level of tech? And from a tech point of view, do you want soldering equipment? Do you want a 3D printer? Do you want tech testing equipment? So that's where I've got kids who have done 2 or 3 steps, and they've proven that they can do some of this technology. Now let's get a little bit more serious and get them something for home that they can start building stuff. The final part of the grant is a few $100 to support a final project. So a kid knows that a stepper motor works, but now they want 4 stepper motors. Well, stepper motors, $20, $25 if they're good ones. So that's where that might take a year or more. I'm not sure how quickly the kids will go through this. And that's another exciting thing that hopefully starts when that money shows up. What's nice with the project I'm working on is, say I'm successful and I have a couple of kids who can do some of this without being in my class. They're doing it all from videos online. Then it might be fairly easy for another teacher in another school to apply for a grant, because they know they have this student who could really benefit from it. And that teacher would really only have to show them my videos and watch the occasional video from the student when they get things working. And so now this teacher can purchase some tech equipment, but hand it out when the kid has got to a certain level. And it might make it really easy for teachers. In the teaching profession, you have every class, you have 1 or 2 kids who are really quite good at tech. And as I've mentioned, some families purchase this equipment for them. My grant should allow that equipment to go to kids who aren't in a situation where the family can just buy them a $100 microcontroller, which if you hook up a wire incorrectly, you break. That's not in every family's realm. So that's the thing with this grant, is I'm going to test out whether the kids can do the work online. And then it might be helpful for other teachers who identify a kid who's really quite tech capable and be able to support them if they can also get a grant. Throwing in the machine learning is actually quite impressive when you're asking for some money to actually have kids do some machine learning. It's just an impressive way to get kids using coding because coding is typically just on the computer. Actually making products that use coding is pretty impressive.
So at last, what do you say to the people who are watching and listening to our conversation from anywhere on this planet?
Well, technology is pretty impressive, and you can learn, like your videos that you're making, you can learn a lot from YouTube and searching out what you want to learn. I use the Arduino Portenta, which is quite an expensive Arduino. I also have this. It is the Arduino Chow, XIAO. I have no idea if I'm saying it properly. It's $5. And it might not run all my code that's been tested on the Portenta, but I use this for testing a circuit that the kids have created on their own. And now you're getting into the part of you can do some robotics, and this can actually do some machine learning, quite simple machine learning. It's an impressive little board. So people around the world, start using your hands and trying some of this stuff that's the basics for robotics, because not everybody's good at it. Some kids just plugging in the little wires in the right part of a breadboard. Some kids have a hard time. And even if you're good academically, it doesn't necessarily mean you're good at this. I have a few kids from the automotive shop, carpentry, working a wood shop, who love doing this stuff. And it's kind of rare to get the kid who is good hands-on, working with their hands, and is doing well at all the sciences, the chemistry, the physics, the earth science, the biology. If you are one of those kids who likes working with electronics and is doing the science, you could have a huge profession. Machine learning's coming along with the robotics. It's a big deal. So stay with it, world.
So at last, as a teacher, as a person who is into machine learning and robotics, and as a person who understands how things works, you're into IT from long time, and you know how things work. So what do you say about my work? Have you seen any videos of mine on YouTube?
I have seen some of the videos. I've forgotten your background. What's your background in?
My background is I did masters in software engineering and graduation bachelor's in computer science and engineering, and I recently took training as a cloud engineer and AWS cloud engineer and AWS solution architect position. And from last one year, I'm taking interviews of the people like you who are already in the industry from long time and who understood things, how things work. Uh, Not only,
That's
yeah.
that's great, Sai. So you've got, as I said, I teach a coding class. I love it when coding students do the robotics because they already get the software side. Now we physically connect your sensors and actuators, and then you add the 3D printing so they can actually build the structure around their robot. It's a powerful combination. So uh, I'd love to have you in my class. But yeah, for the rest of the world, there are lots of ways to get into robotics. I do this hands-on, which doesn't have a lot of the theory. You've done a lot of the software theory. Um, Lots of people can put this all together and have quite a career. I'm impressed with what you've done. You're doing the software, but you're also doing the interviews. You're getting a chance to meet people from all over the world and take that whole social aspect with the computers and the tech, and that's a huge deal too, and useful. Sai, good for you.
So I'm sure because of you, the robotics field, the people who are into robotics, there will be there will be a huge contribution and your inputs for your kids. I'm sure they become great in the subject that you're teaching, and you'll be the reason for a lot of their growth. I'm sure, because I can see you have a huge knowledge in this field.
My biggest one is getting used to things not working. It's robotics, right? Just because you think it's going to work doesn't mean it's going to work. As I mentioned, it was about a year working with the Portenta before, I was happy with the code. My big one to kids is you learn a bit, and even if it doesn't end up being your final job, knowing software and robotics and 3D printing are all big parts of the future. Um, it's good for them to have done something difficult and to have persevered. That's what I really push is it doesn't work the first time. With 3D printing, my kids often do 3 or 4 prints before they're happy with it. And that's a good life lesson because things aren't easy. And being able to persevere is quite a skill. And I think that's the skill they might get from me more than whether they become a robotics engineer, that they just get that life skill of keep trying. If you're passionate about something, keep trying. There's lots of information out there, and good luck. And same to you there, Sai.
Thanks, and keep going, keep doing what you love, and create more things.
Great. Have a good night or day.
Yeah, yeah. Can I put this video on my YouTube channel with your permission?
For sure. And send me a link, please.
And yeah, sure, I'll send. And also, can I put this video and audio clip on my podcast, website, internet, social media, everywhere with your permission?
For sure. Yeah.
Yeah.
Once again,
Awesome.
send me links to everything you put it on.
Yeah, I'll send you once I publish it.
Yeah. Okay. Have a good day.
Yeah, have a good night.
Yeah.